Good morning to one and all. I am Parthivan working as assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Magadu, Chennai. Now I am going to talk about the subject called electron devices, which is coming under the regulation R 2025. The subject code is EC25C01. I am going to talk about the unit 5, particularly about the SCR, that is silicon controlled rectifier. Actually, SCR is a four-layer, three-junction semiconductor switching device belonging to the thyristor family. It was introduced by the Bell Laboratories in the year 1956. The SCR can act as a rectifier, or it can also act as a switch, or can act as a power control device. Unlike a normal diode, the SCR can be turned on only by applying a gate signal. ACR has namely four semiconductor layers, that is called PN, PN, forming three PN junctions, that is junction J1, J2, J3, where there are three terminals will be there. The three terminals are called gate, anode and cathode. The important features of SCR are high voltage capability, high current capability, low conduction loss, fast switching, and it is very reliable. So, because of these factors, SCR is more popular. You see the symbol of SCR, which resembles as if like a diode with the additional terminal that is called a gate. Anode is one where the current enters into the device. Cathode is the one where the current leaves from the device. Gate is the controller which controls the switching operation. So the internal structure typically resembles a two diode back to back and connected PN like that. It is having the three junctions J1, J2, J3. Initially, the mode of operation was J1 is forward biased, J2 is reverse biased, as well as J3 is forward biased. Because J2 is reverse biased, the current cannot flow. After applying the gate current, the J2 becomes conductive and the SCR becomes turns on. The important feature is gate only controls the SCR. So it cannot switch off the SCR. It can only able to turn on the SCR. Actually, coming on to the biasing of these two transistors, actually we can say that it is an analogy of two transistor equivalent, that is a PNP transistor and NPN transistor connected together. Actually, from the diagram you can see first PNP is NPN. If both combined together, they will form like a PNPN structure. So, which is a very familiar thing that you have to note into that. Here also there is an analogy equivalent in terms of symbolic representation also done. So first transistor is an NPN transistor, the next transistor is PNP, both connected back to back together, forming the gate, cathode, anode. So this structure also you have to remember, since it represents the analogy nature of SCR with transistors. Then coming on to the biasing of SCR, we can say the FPR under forward bias, that is anode is positive, cathode is negative. So the conditions are J1 forward bias, J2 reverse bias and J3 forward bias, but the SCR remains off. So after the gate pulse, the gate current reduces the diffusion width at J2, then the current starts flowing, then the SCR switches on. In the reverse bias mode, the cathode is positive, the anode is negative, all the junctions block the current. So SCR behaves as if like a reverse bias diode. So this is the basis of operation for the SCR. So in the SCR stage 1, it is acting like a forward blocking region. The current is very small. The SCR behaves as if like a open switch. In the stage 2, with the help of gate triggering, there is a small gate current that will flow. Then J2 will break down as well as the SCR going to turn on. Under the stage 3, that is a forward condition, large anode current flows. The voltage drop across the SCR approximately to 1 to 2 volts. The power loss is low. So these are the things that you have to observe in the point of view of operation. There is a critical value that is called forward breakover voltage. When it is reached, the junction J2 breaks down and the SCR switches on suddenly. So the characteristics, typical characteristics of SCR is represented by means of a VA characteristic. So once turned on, the current continues until the anode current becomes less than the holding current. So there are some turning off methods are there. So obviously we have to rely on these three methods only. The first one is to reduce the supply current. The second one is AC zero crossing. The third one is forced commutation. These are the three methods available to turn off the SCR. From the diagram you see if there is a latching current is there is a holding current is there. So if anode current exceeds the latching current, the SCR remains on permanently until the current drops below the holding current. So the difference lies in the latching current and holding current you see visibly from the diagram. So latching current needed immediately after triggering. Holding current is the minimum current which is needed to keep down on the SCR always. So latching current will always be greater than that of holding current. So from the slide we can observe that the VI characteristics, it shows the reverse blocking region as well as the forward blocking region as well as the forward conduction region. So these are the various regions that have been marked in the diagram. So the effect of gate current always will be there. Higher the gate current, lower the breakover voltage, earlier will be the switching. So these are the important points that you have to note from the graph. There is a forward breakover voltage is there, which is nothing but the voltage at which the SCR turns on without any gate signal. That is called forward breakover voltage. There is a latching current that will be there. It is a minimum current required immediately after triggering, that is called latching current. Holding current is the one which is nothing but the minimum current to maintain the conduction. There is another thing is that is called reverse breakdown voltage, which is nothing but the maximum reverse voltage that the SCR can withstand. So these are the important parameters that we have to find out from the SCR. So you see the gate characteristics of SCR. So where the parameters are gate voltage, gate current and gate power. These three things controls the characteristics of the gate. So that only decides the operation of SCR. So increasing the gate current always will reduce the breakover voltage and improve the triggering as well as faster switching. So for safe operation, the gate current should never exceed the maximum rating, otherwise it will have the permanent damage that will happen. So these are the points that we have to know. So coming on to the various applications of SCR, SCRs are used as a control rectifier, SCR for motor speed control, SCR can be used as a light dimmer, SCR can be used as a heater control, SCRs can be used for battery charges, SCRs can be used for UPS systems, SCRs can be used for HVDC system, SCR can be used for welding equipments, SCRs can be used for induction heating, static switching, as well as more and more advantages are there. So it has a very good advantage of higher efficiency, higher capability, higher current rating, smaller gate power, very reliable, long life, rugged construction, low maintenance and low cost. These are the features that we have to take into account. So these are the references that I used to refer for the above topic. So thanking you one and all for hearing my lecture patiently. Once again, thank you all.